Alright, so I gave you one question to find out the order of the dipole moment, right? Ankit?
Yes, sir.
NH3, NF3, NCl3, NBr. So let us see. We have NH3. Okay, we know that the direction of the dipole moment is this, towards the lone pair. This is the direction, this is the direction, this is the direction. So overall upward. Yes or no?
Yes, sir.
Then we have NF3. Down, 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 up, overall down. And some effect is cancelled also. NCl3. Up, 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 up. Overall up, but obviously less than NH3 for obvious reason, because the electronegativity difference here is less as compared to NH4. Yes or no?
Yes, sir.
Overall up, more than this NCl3 but lesser than NH3. Okay, so if I ask you to arrange them in the increasing order of the dipole moment, then NH increasing order, right? So NF3 is having the least because there is some cancellation. Then it is followed by NCl3. Then we have NBr3, and NH3 is having the maximum dipole moment. Tell me if this is clear.
Yes, sir.
Tell me if this is clear. So V, where were you? Yes. So V, why were you missing from the classes? I hope you have watched the recording. Yes? Alright. And I gave you one more. If this is the thing, CF3Cl. Sorry. If we have CH3F, CH3Cl, CH3Br, CH3I, then you would say, sir, this should be the order for obvious reasons, because CF bond is most polar. Yes or no? Tell me, fluorine being most electronegative, the CF bond is the most polar among A, B, C, D. This is expected. But the real order is that CH3Cl is having more dipole moment as compared to CH3F, and then CH3Br and CH3R. If you remember, I told you that this is the case where distance dominates. Distance is the predominant factor. Yes or no?
Yes, sir.
So we have dipole moment. We have dipole moment is the magnitude of the charge into the distance. So this distance is significant here. That fluorine is smaller in size. When you move to the next successive member, that is chlorine, the size increases significantly. Okay? Because of that, dipole moment increases. I mean, dipole moment of CH3Cl is more than CH3F. I hope this is clear.
Yes, sir.
Then I gave you this CCl4, and we have just a second CCl4, CHCl3, CH2Cl2, and CH3Cl. Right? So we have CCl4. This was your homework, right, Ankit?
Yes, sir.
So mu is equal to 0. Mu is equal to 0 because I told you that if the central atom is having no lone pair and all the side atoms are same, then the dipole moment is 0. Right? Then we have CaCl3. This is CaCl3. Down, down, up, down. Overall down. Then we have CH2Cl2. Up, down. Just a second. Here is going.
So in the second part, it will be upwards.
Yes, it will be upward. And then this is the case. To get the overall upward. And finally we have overall upward. So as it can be clearly seen, CH3Cl is having the maximum dipole moment, followed by this is 2, and this CH2Cl2. Then we have CHCl3, and finally CCl4, which is having 0 dipole moment. Tell me if this is clear.
Yes, sir.
Clear? Tell me if this is clear. Clear, because obviously there is more neutralization. See. Having said that, did I tell you percentage ionic character, how to calculate, Ankit? Yes, tell me.
So please repeat.
So see, we saw that if this is a covalent bond, and I'm saying that the difference in electronegativity is not equal to 0, then there is a formation of, or there is a creation of a polarity. Yes or no? Like this is suppose,
Yes, sir.
suppose chi B is greater than chi A, then this is partial negative, this is partial positive, and I'm saying that covalent bond has got ionic character. Yes, ionic character has been developed in a covalent bond. So if I want to calculate the percentage ionic character in a covalent bond, percentage ionic character in a covalent bond, then it is basically experimental dipole moment divided by theoretical dipole moment. Theoretical dipole moment into. Now what is theoretical dipole moment? When you are considering the bond is 100% ionic. Bond is 100% ionic. Bond is 100%. Bond is 100% ionic. Okay. For example, if I have NaCl, I know that it is not even partial. These are the complete charges like this. So if I am saying the distance, the interatomic distance, the interionic distance is d, then what is the dipole moment? Dipole moment is magnitude of this charge, whatever charge is, let me write it q, into this interatomic distance. Now, can I say that this charge is plus 1.6 into 10 to the power minus 19 coulomb, and this is minus 1.6 into 10 to the power minus 19 coulomb? Yes or no? Tell me. Yes?
Yes, sir.
So, this is basically 1.6 into 10 to the power minus 19 into D. D will be given in the question, experimental mu will be given in the question, you can easily find out the percentage ionic character. Alright, chaliye, let us do a question on this. Let me give you a question. The dipole moment of Hbr, the dipole moment of Hbr is 2.6 into 10 to the power minus 30 coulomb meter. If percentage ionic character is percentage ionic character is 11.5, calculate the interatomic spacing. Calculate the interatomic spacing. Tell me what it is. That means percentage ionic character is equal to experimental mu, which is given 2.6 into 10 to the power minus 30 divided by theoretical, which is 1.6 into 10 to the power minus 90 into this interatomic distance into 100. And this percentage ionic character is given 11.5 is equal to 2.6 into 10 to the power minus 30 divided by 1.6 into 10 to the power minus 90 into D into 100. Please find out D. Please find out D. Tell me if this is clear.
1.4 into 10 raised to the power minus 10.
1.4 into 10 to the what? 10 to the power
minus 10.
minus 10 meters, right?
Yes, sir.
Or 1.4 angstrom. Or 1.4 angstrom. I hope everyone is getting the same answer. Tell me. Alright. Okay. Next. Now we will see. Now I want to tell you something. Suppose, now I am considering basically now we are doing the chemistry of ionic bond. We have seen the chemistry of covalent bond. Let us see the chemistry of ionic bond. Now I am considering an ionic bond and I am saying that suppose this is my cation, which is usually smaller in size as compared to the anion, and this is my anion. Now let me draw it. This is my cation and this is my anion. Any problem?
No.
Because anion is written. Now this is my ionic bond where I am considering that the positive and the negative ions, they are close enough, like they are almost touching each other. Now this is the electron cloud of this anion. This is the electron cloud of this anion. Now what happens? Since cation is smaller in size, can I say it is having more of Z effective? Tell me, yes or no?
Yes, sir.
This is smaller in size, so can I say this is having high charge? Wait, can I say that cation being smaller in size has high Z effective? Yes or no? Tell me. Now due to which,
yes, sir.
due to this high charge, it distorts the electron cloud of this anion. What I am saying is that due to high charge density or high nuclear charge, high Z effective, what happens? It distorts the electron cloud of this anion towards itself. How? I am saying that it distorts the electron cloud of the anion towards itself. Now what happens? Electron cloud is concentrated in this region. Any problem? Tell Any problem?
No, sir.
I am saying electron cloud is concentrated in this region. And because of that, there is hypothetical polarity which is generated. I am saying this is my negative end and this is my positive end. I mean positive with respect to this one. Tell me if this is clear.
Yes, sir.
Yes? Yes, tell me if this is clear. So a small cation distorts the electron cloud of this larger anion towards itself, due to which there is a hypothetical polarity which is generated. I am writing partial negative here and partial positive here. Take it. Now, let me consider a covalent bond AB, and what I say is that atomic orbital, half-filled atomic orbital of A overlaps with the half-filled atomic orbital of B. This is my nucleus, this is my nucleus of atomic orbital B, and this is my overlapping region. This is my overlapping region. Tell me yes or no?
Yes, sir.
And in this overlapping region, the electron density is high. What does this signify? This signifies that electron density is high in this region. Tell me yes or no? This overlapping region means that electron density in this particular region is high. Similarly, if you compare the ionic bond or ionic interactions with the covalent bond, can I say that the electron density, just like here, is increased or is concentrated between the two nuclei, the nucleus of the cation and the nucleus of the anion? Tell me yes or no?
Yes, sir.
Yes, that the electron density is concentrated between the two nuclei, just like the case we see in the case of covalent bond. So can I say that the covalent character has developed in an ionic bond? Tell me yes or no? Can I say that a covalent character has developed in an ionic bond? Yes?
Yes, sir.
So, which means this implies that covalent character developed in an ionic bond. Tell me if this is clear. Yeah? Tell me if this is clear. Alright.
Yes, sir.
Alright. Having said that, now the distortion of the electron cloud of the anion towards the cation is called polarization. Okay. Now, the tendency of a cation to distort the electron cloud of an anion towards itself is called its polarizing path. Okay. Now, it's called its polarizing path, and the tendency of an anion the tendency of an anion to get its electron cloud distorted, by the cation, is called its polarizability. Polarizability. Tell me if this is clear. Yes? Tell me if this is clear. Polarization is the distortion of the electron cloud. Polarizing power is the power of the cation to distort that electron cloud towards itself, and polarizability is for the anion. Tell me if this is clear.
Yes, sir.
Alright. Now, when I talk about polarizing power of a cation, I am saying it is directly proportional to charge density. It is directly proportional to charge density. Charge density means charge upon size. Charge upon size. That means it is directly proportional to charge on cation, and it is inversely proportional to size of cation. Any problem? Tell me. Any problem?
No, sir.
Okay. Can I say that high positive charge plus small size means more polarizing power? Yes or no? Tell me. More polarizing
Yes,
power?
sir.
Alright. Next, polarizability is directly proportional to the charge on anion. And is also directly proportional to the size of anion. You know why? Because the larger the size of the anion, the electron cloud is far from the nucleus. Yes or no? Larger the size of the anion, more will be the electron cloud which is farther from the nucleus. More farther will be the electron cloud from the nucleus. Hence, its distortion would be easier. Tell me if this is clear.
Yes, sir.
Yes. So can I say that high negative charge plus large size it means more polarizability. Yes? Yes or no?
Yes, sir.
Now, polarization is directly proportional to polarizing power, is directly proportional to polarizability of the anion. Obviously this is for cation, this is for anion, and which is directly proportional to the covalent character. In an ionic bond. Tell me if this is clear. More the polarization, more will be the covalent character, because more the electron density will be concentrated between the two nuclei, which is basically the same scenario like the case of covalent bond. Tell me if this is clear.
Yes, sir.
Yes? Okay. And this is basically the qualitative measure of covalent character, which is based on Fajan's rule. Tell me if this is clear. This is basically the thing which is said by Fajan. Polarizability, polarization, polarizing power are the words from the used by Fajan. Tell me if this is clear. Clear?
Yes, sir.
Very quickly then. Polarizing power. Please arrange the following cations in the increasing order of polarizing power. Very quickly. Again, keep on doing. Keep telling me. Very quickly. Tell me.
Fine, first lithium will be having maximum, then sodium, then potassium, then rubidium, then cesium.
Alright, and the second one? The same?
Yes, sir.
The third one?
Then B3 positive.
Okay, the fourth one?
Na positive is maximum.
No. No. Think about it. Think about it. See, I need to tell you something. First of all, if you clearly see group number 11 and group number 12. In 11 I have copper. If I write copper plus, Ag plus, and here if I write Zn2 plus, cadmium 2 plus, mercury 2 plus, all of these are having pseudo noble gas configuration. Remember, I told you, completely filled D.
Then Sp and D.
Yes, completely filled D. Pseudo noble gas configuration. Tell me, yes or no?
Yes, sir.
So please remember, whenever you have pseudo noble gas configuration, the polarizing power is always greater than the noble gas configuration. In the case of sodium, in the case of calcium, we have the noble gas configuration. Whereas in the case of silver plus, Ag plus and Cd2 plus, we have the pseudo noble gas configuration. So one thing is very clear, that these are going to have more polarizing power than the Na plus and Ca2 plus. Tell me if this is clear.
Yes, sir.
And what about this? These are non-noble gas configurations, the p block elements. So remember that non-noble gas the first, then we have pseudo-noble gas, and finally we have noble gas configuration. Tell me if this is clear.
Yes, sir.
And you know why? See, I can give you a reason also. See, let me tell you a reason. So in the pseudo-noble gas configuration, we have the d orbital involved. So suppose this is my nucleus, this is my s, this is my p, and this is my d, and then I have a big anion. So what happens if I draw it here, d? This is my d orbital, yes or no? And here,
Yes.
and here I am having a big anion. So what happens? D is diffused. What is diffused? Diffused means that the electron densities is scattered. It is scattered in this lobe, in this lobe, in this lobe, in this lobe. It is not uniform. It is scattered everywhere. So D orbital is diffused. D orbital is diffused, and because of that, what happens? The nuclear charge. Acha, this you know that S and P are acting as the shielding cover. Tell me, yes or no? S and P are acting as the shielding cover. They are screening the nuclear charge to reach to D.
Yes, sir.
Yes, but still the nuclear charge is reaching to D, right? So what happens? The nuclear charge has enough space to escape out. No, to escape out as in to leak out. See, nuclear charge can leak out from here, can leak out from here, can leak out from here, leak out from here. Why? Because of its diffused nature, and because of that we have a lot of nuclear charge which has leaked out, and this nuclear charge is basically distorting the electron cloud of this. And I tell you this is clear. Because of the leakage of the nuclear charge. And why is the leakage happening? Because of the diffused nature of this d orbital. Tell me if this point is clear.
Yes, sir.
Yes. So the more the diffused orbital, mean the orbital which is becoming more diffused is basically undergoing more leakage of the nuclear charge, and that is the nuclear charge which is basically attracting, pulling this electron density, electron cloud of anion towards itself. And this is the reason why, the ions which are having pseudo-noble gas configuration have more polarizing power. Polarizing power matlab the power to distort this electron cloud towards itself. Tell me if this point is clear.
Yes, sir.
Alright. So please remember this. Alright. And rest is fine. Yes, but I want to tell you one thing, that we wrote that polarizing power is inversely proportional to size. So if I move across a period, down the group is very much clear, but if I move across the period, for example, I am moving in the second period, so I have lithium plus, beryllium 2 plus, then we have, I want to tell you one thing. First of all, these are having the maximum polarizing power in a period. Maximum polarizing power in a period. You know why? Because of their small size and high charge density. With small size, they have high charge density also. So because of high charge density. Because of high charge density. Because of high charge density, and you won't believe that although lithium plus is having the noble gas configuration, but it is having more polarizing power than Cu plus. Tell me if this point is clear. Than Cu plus. Tell me if this point is clear. Clear? Because of this high charge density, they are small size and high charge. So these are the exceptions. And beryllium 2 plus is having, in fact, this is having the most polarizing power. Then we have Zn2 plus. Tell me if this is clear. Please remember. Clear?
Yes, sir.
Alright. And what about the polarizability? What about the polarizability? Polarizability is simple because usually the anions have noble gas configuration, so it's not a big deal arranging them in the order. So suppose if I have this, very quickly, tell me, arrange the following in the increasing order of polarizability. Very quickly.
Sir, iodine is having maximum.
Maximum because larger the size, more. Okay. What about the second one?
N3 negative.
Yes, nitride, then oxide, then fluorine. What about this? Again, selenide, then sulfur, and sulfide, and then oxide. Tell me if this is clear.
Yes, sir.
Alright. Now, please arrange the following in the increasing order of covalent character. Okay, first, very quickly. LiCl, NaCl, KCl, RbCl, CSCl. Very quickly, increasing order of
LiCl is having maximum.
yes, covalent character. Okay, because because anions are common, so neglect the anion. Just look for the cations. Cations are basically, we know that smaller the cation, more will be the covalent character. Second, Na2, MgO, CaO. Tell me, not CO. Let us make it aluminium. Very quickly.
Na2O.
No. Oxide is common. We have Al3 plus. So obviously Al2O3 is having the maximum covalent character. Yes or no?
Yes, sir.
Tell me about this.
Beryllium chloride.
Beryllium chloride is having the maximum, then magnesium, then calcium. Absolutely correct. Then if I have NaCl, AgCl, thallium chloride, tell me this is, tell me about this.
TLCl.
ClCl. Tell me. CaCl2, HgCl2 very quickly. This is this. What about this? Tell me.
CaCl2.
No, HgCl2. I told you Hg2 plus is, yes, Hg is having the pseudo-noble gas configuration. What about this? Sixth one. Tell me.
BeCl2.
Very good. Then if you have BeCl2, BeSO4, tell me very quickly. Yes, tell me very quickly. Larger the Ni, more will be the covalent character. As simple as that. I hope this is clear. And even if you are not,
Yes, sir.
even if you are not comparing with size, you can compare it with charge. SO4 negative, Cl negative. All right. Now,
Yes, sir.
please do not get confused with BeCl2. So you say that they are two chloride. No, anion remains the same. That is chloride. As simple as that. Like for example, the second one, anion is the same. That is oxide. Okay.
Yes, sir.
Now let us see the applications of Fajan's rule or applications. Applications of Fajan. Fajan's. Number one is your thermal stability. Now this will help you in the S block also. Thermal stability. Now see, what अच्छा thermal stability मतलब एक बात बताओ. When we used to study about ionic bond and covalent bonds, we say that ionic bonds are made up of basically these are formed by electrostatic, strong electrostatic forces of attractions, and because the interactive forces are so strong, they have high melting and boiling point. Tell me yes or no?
Yes, sir.
Whereas covalent bonding may we discuss about the weak van der Waals forces of attractions. Yes? So,
yes, sir.
So can I say that basically what Fajan said is, Fajan's statement kya thi? Fajan, according to Fajan, covalent character, if it is increasing, obviously ionic character will decrease. Yes or no? So if
yes, sir.
So if I ask you that arrange the following in the order of ionic character, then please reverse this order. So covalent character increases, ionic character decreases. Can I say if ionic character decreases, thermal stability decreases?
Yes, sir.
Thermal stability is कि the bond is strong. The bond is strong. It is not breaking easily. The thermal stability decreases. Yes or no? This is a statement given by Fajan. So according to this statement, if I ask you, can you please arrange the following in the order of thermal stability? Very quickly. Tell me.
Yes. CSOH is having maximum thermal stability.
CSOH is having maximum thermal stability. This. Yes, is that what you are saying?
Yes.
Is Is that what you are saying?
Yes, sir.
Okay. And if I ask you this, Lii, Nai, Ki, Rbi, CSI. Tell me, what about this?
PSI.
CSI is having more. This is what you are saying?
Yes, sir.
Tell me, is that what you are saying?
Yes, sir.
So I am saying that this is correct, but this is wrong. But this is now. Now, why this is wrong? First of all, let me introduce a concept to you, and that is the concept of lattice energy. That is the concept of lattice energy. And it says basically what is lattice energy? The amount of energy released, when 1 mole of an ionic compound, is formed from its gaseous ion. So for example, if I am talking about NaCl, the formation of NaCl from its constituent ion in the gaseous form, then the energy released is basically the lattice energy. Tell me this is clear.
Yes, sir.
Now, can I say that more the lattice energy means that obviously the bond, if the bond is strong, then more of the energy is released? Yes or no?
Yes, sir.
And if more the energy is released, can I say that more will be the energy which is required to break that bond?
Yes, sir.
And hence more will be the thermal stability. Now, according to Bondland, basically this is Bondland equation, which relates lattice energy with size. Basically, it says that lattice energy is directly proportional to the charges on the anions into charges of the cation, divided by the distance between the anion and the cation. Now, since I gave you this, since this is basically, here the distance is less, here the distance is more, here the distance is still more. Tell me yes or no? The R is increasing in this order, from left to right.
Yes, sir.
And if R is increasing, the thermal stability or the lattice energy is decreasing, and hence thermal stability is also decreasing. So that is why Lii is having the maximum thermal stability. Tell me if this is clear. Yes? Tell me if this is clear. But now,
Yes, sir.
the two statements are contradicting. They are contradictory. Yes or no?
Yes, sir.
So how would you write the correct order? So basically here is what we saw an anomaly in the Fajan's rule, and just you need to remember this, what I am writing. Whenever you have a question on thermal stability, your first thing is to check the anion. Your first task is to check the anion. Once you have checked the anion, there are two possibilities. The anion can be monoatomic. Like F negative, Cl negative, I negative, N3 negative, O2 negative, such these. And anion can be polyatomic, like OH negative, NO3 negative, CO3 2 negative, SO4 2 negative, etc. Tell me if this is clear.
Yes, sir.
So if it is monoatomic, you will use lattice energy concept. So you will report the answer using lattice energy, and if it is polyatomic, you will use Fajan. Tell me if this is clear.
Yes, sir.
Tell me if this is clear. So please remember this. Whenever you have for thermal stability, you are supposed to check for the anion. Once you are, you know the anion, then we have the two possibilities. The anion can be monoatomic or polyatomic. If it is monoatomic, go for lattice energy concept. That means bond length equation. And if it is polyatomic, just go for the Fajan's rule, which says that more the covalent character, lesser will be the ionic character, and hence lesser will be the thermal stability. Tell me if this point is clear.
Yes, sir.
Alright then. So suppose if I give you one or two questions based on this. Alright. Tell me. CaSO4, ZnSO4. Very quickly.
So ZnSO4.
Thermal stability. Water. ZnSO4. ZnSO4 is having more of the covalent character. So obviously CaSO4 is having more thermal stability. Yes or no? ZnSO4 is having
Yes, sir.
ZnSO4 is having more of covalent character. So CaSO4 is having more of thermal stability. Now what about the second one?
The MgOH whole twice.
What MgOH whole twice? Maximum?
Yes, sir.
Followed by
Zinc.
followed by
Beryllium.
followed by beryllium, followed by this.
Yes.
This is wrong. This should come here. This is having the least covalent character. This is having the least covalent character because this is +1. These are +2. So this is having the maximum thermal stability. LiOH is having maximum, followed by MgOH whole twice. Then we have ZnOH whole twice, and then we have beryllium OH whole twice. Tell me if this is clear. Tell me if this is clear.
There are so many exceptions are there.
What exception? I haven't seen any exception. Yes, Shanmuka, have you seen any exception? Except this. So that you don't want to get confused in the exceptions. That's why I have given you such a beautiful thing. Such a beautiful thing. Just need to remember this. What do you expect? Anything simpler than this? Yes, what is the exception here? What is the exception here? You don't know that this is +1 and these are +2, so obviously +1 is having the lesser covalent character, and if it is having the lesser covalent character, it is going to have more of thermal stability. What is the exception here? This is the common sense, not exception. I hope this is clear.
Yes, sir.
And Ankit, I do not expect such things from you at least. This is not an exception. This is a common sense. Li plus, Li2 plus. Okay. Alright. Now, jokes apart, this is obviously because this is something new. But trust me, Ankit. Trust me. You are starting this. This is going to help you in the S block also. When you are asked to arrange the carbonates and sulfates in the solubility order, the thermal stability order. Trust me, these things will help you there. Okay, obviously because this is the first time that I am introducing you to such a thing, but trust me, once you are used to it, the things will be very simple. Okay?
Yes, sir.
Okay. And all the possibilities I am making you do here, so you do not have anything left. That is why I keep on saying, please go through the notes, you don't have to do anything. Chaliye, next, we are already doing more than enough. So you don't have to read 100 books now. Next is, next application is solubility. So solubility, maybe I can see. I'm just going directly to the trick. The trick part is that whenever you have hydroxides of group 1 and group 2, जैसे कि LiOH, MgOH whole twice, okay? MgOH whole twice, yes. Whenever you have hydroxides, then you will go for, you will arrange the the hydroxides in the order of solubility using Fajan. And what it says that more the covalent character is inversely proportional to the solubility. And what solubility, when I am using the word solubility, I am talking about the solubility in the polar solvent. If it is in non-polar solvent, just reverse the order. Because you know that light dissolves light. So ionic compounds are soluble in polar solvents. I hope this is clear.
Yes.
Yeah. So, and why is this happening? Because you know that if the thermal stability, and I hope you know this, covalent character is inversely proportional to solubility. Yes? Tell me if this is clear. Now I'm just doing the trick part. You do not have to get confused. Okay? Now, and one more trick, that suppose if you have a smaller cation and a smaller anion, and if you have a larger cation, larger anion, then in these cases it is less soluble. And if you are having smaller cation, larger anion, then in this case it is more soluble, as simple as that. Now let me give you a question, and this is very much clear. I am giving you a question based on this. Now write it down. So suppose if I give you, let me give you a question. Solubility, LIF. Okay. Suppose if I give you this NAF, LIF, NAF, KF, very quickly. Smaller, less soluble. So obviously this is the order. Tell me if this is clear.
Yeah.
Yes. Solubility. Is it clear?
Yes, sir.
Yeah. And if I write this, LII, NAI, KI, very quickly.
LII.
Good. So where are the exceptions? Where are the exceptions? This is as per the trend. Where are the exceptions? And why? And see, I can also give you the reason. This is very simple. If you think about it, it's very simple. Small. Can I say small means more strong bond? Tell me yes or no?
Yes.
And if the bond is strong, obviously, hydration energy will be less. And if the hydration energy will be less, it is less soluble. As simple as that. In order to break those, separate or ionize the compound, more energy will be required. So it is less soluble. Tell me if this is clear.
Yes.
And strong, large, matlab the bond is weak. Here the bond is weak. If the bond is weak, it can the solvent can easily ionize the compound. Bond is weak. Bond is strong. Alright?
Yes, sir.
Alright, so if the bond is strong, lattice energy dominates over hydration energy. And here, hydration energy dominates over lattice energy, as simple as that. Chaliye. Now, the topic that I am going to do now is basically, we will see the questions of this topic in the chemical thermodynamics chapter. But yes, since I have introduced you to the concept of lattice energy, I want to discuss this topic here only. And this is to find lattice energy. Now see, there is no direct method to calculate the lattice energy. There is no direct method. But we have an indirect method. To calculate lattice energy using Born-Haber cycle. Born-Haber cycle. Alright, now see what it is. Now, usse pehle, I want to tell you one thing. Now, lattice energy, we have already seen the definition, I am writing it again. The amount of energy released when 1 mole of a compound is formed from its constituents. And what is heat of formation? This is heat of formation. What is heat of formation? Heat of formation is the amount of energy released when 1 mole of a compound is formed from its constituents. Now you will say, sir, why are you bluffing us? Yes or no? I have written the same definitions. Yes? Tell me.
Yes, sir.
Now the difference is that it is formed from its constituent gaseous ions. And this is formed from its constituents in pure state, pure or elemental state. Like I said, we will see more of it in the thermodynamics chapter. Okay. Now, see, I am taking the example of formation of NaCl. If I write formation of NaCl like this, Na plus gaseous plus Cl minus gas, then the energy released in this case is the lattice energy. And the same formation of Cl, NaCl, if I write it in this manner, we find Na in the solid state, yes or no? And we find chlorine in the gaseous form. So this is Cl2 gas and lead up. Then the energy release is your heat of formation. Tell me if this is clear. This is the difference.
Yes, sir.
Okay. So now we will calculate the lattice energy using this. So see, first of all, what I am supposed to do is, let me write it in this manner. Now see, first of all, I need to change it into Na gaseous. Yes or no?
Yes, sir.
And what is this energy?
Sublimation energy.
And the sublimation energy is endothermic or exothermic process? Endothermic. So basically we are going to supply the sublimation energy. Then I need to convert it into Na plus in gaseous form. What is this energy?
Ionization enthalpy.
Now, first I need to convert it into Cl gas. What is this energy?
Atomization enthalpy.
Dissociation energy. And since I am having half molecule, so I will be supplying half of dissociation energy. Clear?
Yes, sir.
And what is this?
Ionization enthalpy.
Electron gain enthalpy. Electron gain enthalpy. Yes or no?
Yes, sir.
Okay. Alright. So this is Na plus, and finally you get this, and in this process the energy released is lattice energy. So see, I can write minus delta HF is equal to sublimation energy plus ionization energy plus dissociation energy upon 2 minus EGE minus lattice energy. Tell me if this is clear. Tell me if this is clear. Everything will be given in the questions. You can do it. Second, suppose if I see the formation of MgO. So basically magnesium in the form of ribbon solid. Then again half O2 gaseous state में I get MgO powder, which is also solid. Now first of all I need to change it into Mg solid, Mg gaseous, which is sublimation energy. Yes or no?
Yes, sir.
Then I need to change it into Mg plus. What is this energy? Plus IE.
Ionization enthalpy 1.
1, because obviously this is Mg2 plus, most stable, plus IE2. Similarly, I need to change it into O gaseous, dissociation energy upon 2. I needed to change it into O negative gases. What is this?
Electron enthalpy 1.
And then O2 negative. Yes, what is this?
Electron enthalpy 2.
With plus sign or a minus sign?
Plus.
Plus sign, because the second electron gain enthalpy is endothermic for obvious reason, Sheetal, because you are adding negative electron to the negative charge, to the anion. So basically there are repulsions. First of all you need to overcome the repulsions in order to add the electron. So that is why you are supposed to provide the energy. And finally you are adding these two, and this is from lattice energies. So how would I write it? Minus delta H of HF right? And what is this? Sublimation energy plus ionization energy 1 plus ionization energy 2 plus dissociation energy 2 minus EGE 1 plus EGE 2 minus any problem?
No, sir.
Okay. And you need to remember that suppose if in the question if you are given ionization energy and some value, that please do not get confused that ionization energy is the cumulative ionization energy for both of them. Like it's a sum of both of these, okay?
Okay.
Alright. So let us practice. We have wrapped up the chemical bonding. Finally, we have wrapped up the chemical bonding. Let us practice. Now I want to tell you something, that from next class onwards, I won't be teaching you, ma'am will be teaching you, okay? Sandhya ma'am will come and teach you for a time being, okay? And please cooperate with her. And Ankit, Sheetal, Shanmukha, Pujita, Reshma, everyone, she will be taking general organic chemistry, okay? She will be taking general organic chemistry, GOC part. Alright? Like I said, Sheetal, I will come back. Most probably just after the GOC. Like she'll be teaching you that one chapter. I'll come after that. And when I'll come, I'll start with states of matter. Alright?
Yes, sir.
Any problem? So she'll be taking general organic chemistry. So please cooperate with her, learn things from there. And I'll be back soon and I'll start with states of matter. Alright?
Yes, sir.
Okay. Now let us practice a few of the questions. I'm not going anywhere, I'll come back. Yes, Sheetal, I'll come back. Which of the following species is not paramagnetic? Which of the following species is not paramagnetic? Which of the following species is not paramagnetic? NOCO O2, NOCO O2, H2. Sorry, B. Done. Okay, you are saying CO, CO. What about others? Yes, tell me. Carbon monoxide. Acha. So will sp mixing occur here or not? Reshma. Will sp mixing take place or not? Yes, tell me. Will sp mixing take place? Ankit?
Yes, sir.
So if sp mixing is taking place, then 1, 2, 3, 4. This is the diagram. And how many electrons in CO? I guess 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yes, it's diamagnetic, so it is not paramagnetic. Absolutely correct. I hope everyone is getting the same answer. Ankush, Avni, Shanmukha, Pujita. Yes, Shanmukha, Avni, Ankush. Alright. Next question. Next question. Among the following, during the change of O2 to O2 negative, during the change of O2 to O2 negative, the incoming electron goes to the orbital. The incoming electron goes to the orbital. It's just the knowledge of MOD, molecular orbital diagrams, nothing else. Phi to be X, Phi to be X star, Phi to be Y, Phi star to be Z. Chali. Tell me.
So pi star to be
Pi star to be X. Okay, let us see. 1, 2, 3, 4, 5. This is the diagram. This is my pi to be X, pi to be Y, This is pi star to be x, pi star to be y. And how many electrons am I supposed to fill? Tell me. O2.
17.
No, O2 base 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17 and 17. So 70 electron is going in the pi star to x. Absolutely correct. Yes, absolutely correct. Tell me if this is clear.
Yes, sir.
Alright. Which of the following have identical bond order? Which of the following have identical bond order? Have identical bond order. Cn minus, A, O2 minus, C, NO plus, and D, Cn plus. Tell me, which of the following have identical bond order? I mean, you are supposed to report the answer like A, B, C, A, B, C, D, like that. Yes, tell me. B and C, okay. C and D, alright. What about others? A and C, okay. Ankush, Ankit, Avni, Reshma.
C and D.
C and D. Is it A or C or C and D? Yes? Acha, how many electrons are there in C and negative? Tell me.
14.
14. And O2 negative?
17.
NO plus?
14.
Cn plus? Quickly. Quickly. 12. So obviously it is A and C. It's A and C. Yes or no? Yes, Reshma. Yes, A and C. Pujita. Tell me if this is clear. All right. Just a second. Sure. Next question is, when N2 goes to N2 plus, when N2 goes to N2 plus, N2 plus, the anion bond distance, anion bond distance dash, and then when O2 goes to O2 plus, and when O2 goes to O2 plus, the O bond distance dash. That means increases, decreases, increases, increases, decreases, decreases, so on. Sorry. Done. Decreases in both the case. Yes, Shanuka, Sheetal have given the answers. What about others? Yes, Ankit, Ankush, Reshma, Avni.
Sir, increase, decrease.
Increase, decrease. Increase, decrease. Sorry. First of all, tell me what is the bond order for N2
3,
and N2 plus
2.5.
2.5. Bond order is decreasing. So bond length is
Yes, sir.
So bond length is increasing. Increases. And what about the next one? What is the bond order of O2?
2,
and O2 plus?
2.5.
Bond order is increasing, so bond distance decreases. Tell me if this is clear.
Yes, sir.
Tell me if this is clear. Yes, sorry. According to molecular orbital theory, last question. According to molecular orbital theory, which of the following will not be a viable molecule? Which of the following will not be a viable molecule? चलिए चल yes, tell me what it is.
Sir, third option is He2 positive.
Yes, He2 positive.
The fourth option.
Where your bond order is coming out to be zero.
Fourth option.
Is it fourth option? Tell me. What about others? Yes, tell me. Fourth option. Sheetal, don't know? See. Sheetal, we have H2. So 1, 2. Sigma 1s, sigma anti-bonding 1s. This is my first hydrogen. This is my second hydrogen. And this is my H2 molecule. So how many electrons am I supposed to fill? 2 electrons. So 1 and 2. Now H2 2 negative means that I am having 2 more electrons, 4 total. You see? So the bond order is coming out to be 0. 1 minus 1. Yes or no? 0. And if the bond order is coming out to be 0, that means bond doesn't exist. Bond doesn't exist. Tell me if this is clear. Yes, tell me if this is clear.
Yes, sir.
Clear? Give me a second. Yes? Alright then, thank you so very much. Do take good care of yourselves. We'll meet in the next, most probably before Diwali. I will see you guys.